We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live.
The cosmos just delivered a 1-2 punch that has experts scrambling. NASA detected not one but two violent stellar explosions, and almost immediately afterward, the mysterious interstellar object 3I Atlas crossed into Mars's orbit. The confluence of these events is beyond coincidental, hinting at a grander, more interconnected universe than we ever imagined. The thing nobody tells you is just how rare such a precise cosmic alignment truly is. We're about to uncover the shocking truth behind these explosive celestial fireworks, the incredible journey of 3I Atlas, and what its dramatic arrival near Mars means for understanding our place in a truly active cosmos. Mars's close encounter. To fully grasp the magnitude of this event, we first need to understand the players. Imagine an object from beyond our solar system traveling through the vast darkness for perhaps millions of years, finally making its presence known. That's 3I Atlas, an interstellar comet that, to put it mildly, has defied expectations. It's only the third such object ever confirmed, following Oumuamua and 2I Borisov, making its very existence a rare gift for astronomers. But 3I Atlas isn't just rare, it's baffling. Observations from September 15th by the Lowell Discovery Telescope, a professional installation, revealed something truly strange, an anti-sunward tail. Yet many amateur astronomers capturing images of 3I Atlas simultaneously reported a tail in the sunward direction. This baffling disparity has scientists scratching their heads. How can the same object exhibit such contradictory behavior? The most shocking fact is that this isn't just a small difference. It hints at forces or compositions we barely comprehend. Meanwhile, while this cosmic chameleon was making its peculiar approach, distant stars were ripping themselves apart in spectacular fashion. These weren't just any bright flashes. These were novae, powerful stellar explosions that can temporarily increase a star's brightness by thousands to millions of times. Two specific novae, V7994 Sagittarii and V1935 Centauri, were detected on September 23rd. V1935 Centauri, in particular, was an absolute showstopper. Discovered by Dr. John Seach, an astrophysicist keenly interested in space weather, it brightened from a magnitude of 10.2 at discovery to a stunning 5.8, making it visible to the naked eye in the southern hemisphere. To give you a sense of this, a change of 1 magnitude means a star is about 2.5 times brighter. So a jump of 4.4 magnitudes means this star became over 40 times brighter in a matter of days. That's a wow factor, something truly incredible. It blasted off gamma rays and hard X-rays, a violent outpouring of energy that traveled across countless light years to reach our sensitive detectors. The immediate arrival of 3I Atlas into Mars's orbital neighborhood, less than 0.2 of an astronomical unit from the red planet, right after these stellar explosions, is what truly sets this event apart. An astronomical unit, or AU, is the distance from Earth to the Sun, about 93 million miles. So 0.2 of an AU is roughly 18.6 million miles, a close shave in cosmic terms. What many overlooked is the delicate balance of our solar system. The solar wind, a constant stream of charged particles from our sun, creates a dynamic environment. Imagine this solar wind hitting 3I Atlas, an object already showing strange tail behavior. The coma of 3I Atlas, the hazy envelope of dust and gas around its nucleus, is estimated to be around 100,000 kilometers or about 62,000 miles in length. But here's a crucial detail often missed. It's not just dust and gas, it's also a significant amount of plasma. 99.9% of the universe is plasma, a superheated, ionized gas. When solar radiation and coronal mass ejections hit objects like 3I Atlas, they can ionize the material, creating this plasma. This plasma interacts with the dust grains, changing the entire dynamic. This makes 3I Atlas an even more unpredictable player in our cosmic neighborhood. The energy from the solar wind, combined with the extreme burst of gamma rays and X-rays from the distant novae, presents a complex picture. These high-energy photons don't just disappear, they interact with everything in their path, including the tenuous gases and dust within our solar system. Could these distant stellar explosions have somehow nudged 3I Atlas, or influenced its trajectory or behavior as it reached Mars? It sounds like something out of a science fiction movie, you see, but not all things are what they seem. We know that coronal mass ejections from our own sun can impact planets, causing geomagnetic storms on Earth and inducing temporary magnetic fields around planets like Mars and Venus, which lack their own strong global magnetic shields. If our own sun can cause such effects, what about a blast from a star light years away? While the direct physical push from distant stellar explosions on a comet is highly unlikely due to the immense distances, the energy signatures, the light and radiation they emit are undeniable. The timing is what is so captivating, almost too perfect. One might wonder if something deeper, a cosmic resonance, is at play. This isn't just about a comet and distant stars, it's about the very fabric of the cosmos responding in concert. We're on the edge of a new understanding. Could these powerful distant explosions be a cosmic signal revealing hidden connections in space? Beyond the nova's glow, understanding exploding stars. The detection of V1935 Centauri and V7994 Sagittarius has thrown a spectacular wrench into our understanding of cosmic events. These weren't mere twinkles in the night sky, these were violent stellar explosions, categorized as novae. But what exactly is a nova, and how does it unleash such immense power across the void? You see, the common understanding often simplifies these events, but the true mechanics are far more intricate and mesmerizing. A nova occurs in a binary star system where two stars orbit each other. Typically, one is a white dwarf, the super-dense remnant of a star like our Sun after it has exhausted its nuclear fuel. The other is usually a companion star, still actively burning. The gravitational pull of the white dwarf is so incredibly strong that it begins to strip hydrogen gas from its companion star. This stolen material piles up on the white dwarf's surface, growing denser and hotter under immense pressure. The thing nobody tells you is that this isn't a slow, gentle accumulation. It's a relentless torrent that gradually builds toward an explosive climax. When the layer of hydrogen on the white dwarf's surface reaches a critical temperature and pressure, typically around 18 million degrees Fahrenheit, a runaway thermonuclear reaction ignites. This is a sudden, uncontrolled burst of nuclear fusion, like a hydrogen bomb exploding on a cosmic scale. The outer layers of the white dwarf are then violently ejected into space at incredible speeds, often thousands of miles per second, creating the sudden, brilliant brightening we observe. The most shocking fact is that a single nova explosion can outshine our Sun by 50,000 to 100,000 times for a brief period. Imagine the energy released. The star 51935 Centauri brightened by a factor of over 40, showcasing this immense power. These explosions, while dramatic, are generally less energetic than supernovae, which involve the complete destruction of a massive star or the collapse of a white dwarf. Novae are more like recurrent stellar fireworks. The white dwarf often survives the blast and can go on to accumulate more material and explode again in the future, sometimes every few thousand years. This makes them fascinating objects for study, offering clues to stellar evolution and the violent processes that sculpt the galaxy. The gamma rays and hard X-rays detected from V1935 Centauri are incredibly energetic forms of light. Gamma rays are the most energetic electromagnetic waves, with frequencies higher than X-rays. They travel at the speed of light, carrying an immense amount of energy that can interact with matter in profound ways. When these high-energy photons sweep through our solar system, they can cause ionization, stripping electrons from atoms and creating charged particles. While the direct impact on Earth is minimal due to our atmosphere and magnetic field, which largely shield us from such radiation, these bursts can still influence the delicate balance of space weather. What many overlooked is that our solar system is not a static bubble. It's constantly bathed in a sea of cosmic rays, solar wind, and occasionally powerful bursts from distant stellar events. The fact that these powerful stellar explosions occurred concurrently with 3I Atlas nearing Mars adds a layer of intrigue. Is it purely random chance, or is there a subtle, unseen influence at play? While direct causation is highly speculative, the universe has a way of surprising us. The energy from these distant blasts could theoretically have contributed to the overall electromagnetic environment of our solar system, perhaps subtly affecting the behavior of sensitive plasma within cometary coma. And you can see this everywhere if you look at how different cosmic events are often linked by their energetic output, even if the connections are not immediately obvious. This suggests that the universe itself might be a much more interconnected system than we give it credit for. What if these stellar explosions are not just distant events, but part of a larger cosmic ballet? A wanderer's strange tale. The interstellar object 3I Atlas is not just any comet. It's a cosmic anomaly that continues to challenge our understanding of space. Its journey, originating from beyond our sun's gravitational reach, makes it a unique visitor, offering a rare glimpse into the composition and dynamics of other star systems. But its behavior as it plunged into our inner solar system, particularly near Mars, has been nothing short of bizarre, leading many people to be crazy about solving its secrets. First detected as a faint smudge, 3I Atlas quickly brightened, not once but twice, exhibiting behavior far from a typical comet. Its apparent magnitude jumped by about 20 times at one point, indicating a dramatic increase in its light output. This wasn't merely due to getting closer to the sun, it suggested a more intrinsic change, possibly linked to interactions with the solar wind, or even speculatively the energetic output from the distant nova explosions. The coma, that fuzzy envelope of gas and dust surrounding its nucleus, expanded significantly, reaching a size of approximately 62,000 miles across. For perspective, that's nearly 8 times the diameter of Earth. This is a wow factor in itself, a cloud of material that vast from a relatively small nucleus. Then there's the tail. The thing nobody tells you is that a comet's tail typically points away from the sun due to the pressure of sunlight and the solar wind. Yet professional observations from the Lowell Discovery Telescope showed an anti-sunward tail, a tail pointing toward the sun, while amateur astronomers reported a tail pointing away from the sun. This glaring contradiction has left scientists puzzled. Could it be a difference in viewing angle, or perhaps two distinct tails? One made of dust and the other of ionized gas, reacting differently to solar forces? Or could there be something fundamentally unique about 3I Atlas's composition or rotation that creates such divergent observations? What many overlooked is that the behavior of plasma in space is incredibly complex, influenced by magnetic fields and electric currents that are not always easy to observe. You see, coronal mass ejections, or CMES, from our sun have impacted 3I Atlas. These massive bursts of solar plasma and magnetic field can carry billions of tons of material away from the sun at speeds up to 3 million miles per hour. When a CME strikes a comet, it can profoundly affect its coma and tail. The current CME impact on 3I Atlas, occurring as it reached Mars's orbit, is particularly interesting because the object is now much closer to the sun than it was during earlier CME encounters in July. Being closer means the CME's impact is far more direct and concentrated, not spread out over vast distances. This more intense interaction could further ionize the comet's material, potentially leading to even greater brightening or more unusual tail formations. The interstellar nature of 3I Atlas means it carries secrets from another star system. Its composition might be entirely different from comets formed in our own solar system, which could explain its unusual behavior. Scientists hope to study its spectral signature to identify the elements present in its coma and nucleus, which could provide clues about its origins. Is it rich in certain elements common in its home system but rare in ours? Does it have an unusual ice-to-rock ratio? These are fundamental questions that 3I Atlas presents. Its very journey across light years, surviving the harsh vacuum of interstellar space, tells a story of resilience and the incredible diversity of cosmic wanderers. And you can see this everywhere in the universe. Every new object brings new questions and challenges what we thought we knew. This object, arriving with such impeccable timing alongside distant stellar explosions, compels us to consider how such seemingly disparate cosmic events might be linked on a grander, more subtle scale. The universe is a vast interconnected tapestry, and 3I Atlas, along with these stellar blasts, is pulling on some very intriguing threads. As 3I Atlas dances with Mars, could it unlock secrets about our own origins? Mars, our crimson neighbor, has a long and turbulent history, one shaped not just by the sun and its own internal dynamics, but also by the occasional dramatic intrusions from the wider cosmos. This journey into the cosmos is just beginning. What other untold secrets do you think the universe holds, waiting to be discovered? Let us know in the comments, and don't forget to like this video and subscribe for more mind-blowing cosmic discoveries.